Hello. Welcome to Darth Dragon Does Math. It's a lightsaber. I don't know if you can tell. I've got the pew pew when you move it around sound turned off, but it's still pretty awesome. I mean, hold on. Just gonna check this thing out. I'm upside down. What do you know? Hi. Thanks for my sweet lightsaber, by the way. I'm not going to say your name online. Keep privacy there. Alright, let's do a couple examples here. If we can get reset up. This was totally worth it. Maybe. Maybe. Alright, we'll go from there. Not much changed. Alright, that's cool. So we're going to expand. If you remember from last video, expanding means rewriting an expression with parentheses, without a parentheses. So we're going to do that by using the distributive property. Now there's a couple ways to do this. The easiest way is to say, well, two of these. I have two of them. So this is basically saying r plus 8 plus r plus 8. And you don't really need the parentheses, r plus 8 plus r plus 8. Well, I have 1r, 2r, plus 8 plus 8, well, that is 16. So this is the same thing as 2r plus 16. Another way to do it is a little easier, I think. Well, easier is a relative term. It takes less room, is to say whatever's here is to multiply it by every term inside the parentheses. So 2 times r is 2r. 2 times a positive 8 is a positive 16. So 2r plus 16. You get the same way, and this is the way I'm going to do it from now on. So if I want to expand 3 times k plus 6, I would say 3 times k is 3k. And then 3 times 6. 3 times 6 is 18. So this becomes 3k plus 18. I can go backwards. Now when I go backwards and I factor, I want to basically get the parentheses back. So if I were to go backwards from here, nobody tells you that 3 is there. You have to find that yourself, and the way to do that is actually to find the GCF of the coefficients of your terms. Okay? So if we're going to factor this, we are going to find the GCF of the coefficients. And as you get a little bit more, maybe you find the GCF of the variables as well, but right now we just have to worry about coefficients. So 2 and 10. So 2, I'm going to factor 2. The 2 factors is just 2 because that's a prime number technically. So 10 is 2 times 5. Now the GCF is the largest one they have in common. So 2 is 2. 10 has a 2 in it, so the GCF is 2. I'll pull out a 2. And so we look back at our terms. So if I were to divide 2y by 2, I would have 1y. And if I were to divide 10 by 2, I would have 5. So to factor 2y plus 10 is the same thing as 2 times y plus 5. And we can check ourselves just to make sure we did it right. We could say 2 times y is 2y, and 2 times 5 is 10. So we are correct. So this right here would be this or that factored. Now this one, the GCF of 6z and 9, well, that's going to be 3. The largest number that can go into 6 and 9 is 3. So we say this is 3 times, and then we start taking out that 3. We take out the GCF. We say, what's 6 divided by 3 is 2. So 2z, and 9 divided by 3 is 3, and we got to make sure that we keep that negative there. So 3 times 2z minus 1, or minus 3. I get to check ourselves. 3 times 2z, if I had 3 2z's, 3 times 2 is 6, so that would be 6z's. 3 times 3 is 9, so this would be 3z minus 9. We did do it right. And now I'm going to talk about equivalency. We talked about equivalent expressions earlier in a different video. But we want to know, are these equivalent? Now, the only way to do that is to check, basically, by either expanding or factoring. So I'm going to do a little bit of both. So if I'm going to expand this, which expanding is probably just a tad easier, 4 times d is 4d. 4 times negative 3. Remember, we got to keep that negative there. 4 times 3 is 12. Now, if this is the same thing as this, they are equivalent, which they are. So we say yes. This one right here. Now, I'm going to actually factor this. I'm going to say, what is the GCF of 12 and 3? 12 and 3x. So, and really we're just worried about coefficients. So say 12 and 3. Well, the largest number that goes into 12 as well as 3 is 3. So I'm going to pull out a 3 from both of these. 12 divided by 3 is 4. 3x divided by 3 is 1. So this would be 3 times 4 plus x. And the question is this the same thing as 3 times x plus 4? So let's imagine, can we move these? Can we replace them? So we say, well, what if we wrote x first? So 3 times, that's a positive x, and that's a positive 4. So if we replace them, okay, now they definitely are equivalent. So are they equivalent? Yeah, buddy. Now, are these equivalent? So this time I'm expanding. So 7 times h is 7h. And then 7 times, that's a negative, 7 times 8 is 56. So we're saying, is this the same as this right here? So 56 is in the front, so let's put the 56 in the front here. And so this is, the whole term is negative 56. So this is negative 56, and this whole term is a positive 7h. Now, this and this are not the same thing. That's a negative 56, that's positive 56. That's a positive 7h, that's a negative 7h. Those are not the same, but this is a mistake so many people make. So I guess the way that I would not make it is understand that the negative travels with whatever number or term, rather, that it is in front of. So make sure that the negative travels. So if I were to flip these, if I were to flip the order of this right here, the negative travels with the 7h. So this is negative 7h. Now there's an understood, if you don't write the negative there, then it's definitely a positive. So the positive travels with that. So if this was what we came up the first time, then they would be, but they're not. And this is, so no. This is another example. We say, I'm going to expand this. 3 times x is 3x. And a lot of times, that's all people do. So we say 3x. We want to make sure that we get both little rainbows here. And I strongly encourage and expect my students to write these rainbows. Because if you write them, you write, okay, 3x, 3 times 1 is 3. You won't make the mistake by thinking these are equivalent. I cannot tell you how many people say 3 times x plus 1 is equal to 3x plus 1. It's not, because we have to do 3 times the 1 in the back. Not equivalent. It's equivalent to that. I'm going to stop there, and I will load one more video for 7.4. Alright. I do not endorse Arvest, it's just my pen.